Yes, thank you very much for the introduction, and also thank you to all the other speakers here today, because it really amazes me to what ROS, and especially in the industry space, is evolving into. But I sometimes have the feeling that the industrial automation, like it is known before, seems to be a book with 1,000 locks to it, and it's very hard when I hear those talks to imagine how people from the ROS universe would create industrial applications at scale. And for that, I just want to give you a little bit more context and try to understand what could be a way to integrate ROS there. It's not 100% this is it, or everything else is bad. It's more like give you some insights about what we as Siemens see happening out there, not only at very large companies like in automotive, but also at smaller industrial companies that needs industrial automation day by day for their business and operations to thrive. Okay, to show you what I really mean, I brought to you today a little story to understand what industrial automation means for businesses. And for that, it's a little time capsule. I brought to you today here John from John's Apples. We are in the year of 1970. And he is a growing business, similar to what Egos is doing today. Robot arms picking apples. Back in the day, it was just people. And they were using no automation whatsoever, but they still needed to process all the apples. They needed to wash all the apples in order that John could sell the apples at the market to their customers. Okay, business is flourishing, but how can they scale? John always hears the automotive, those conveyor belts, amazing, but is this something for John's business? And that's where he's then asking himself, is there something on the fairs? And finally, he buys the Apple Washer 2000. Very great product, highly sophisticated. It has exactly two functions. It has a conveyor belt that drives all the apples forwards, and it has a pressure washing machine which just cleans the apple. And that's it. There's nothing more fancy than that. Just two buttons, starting and stopping. That's really all there is for industrial automation. Still, while it is so simple and it helps John to run his business, a lot can go wrong. Just the smallest things, and that's why John says, hey, I might not need so many people washing the apples by hand, but I might need somebody who can fix my machine when it breaks down. And actually, this machine that John bought there in 1985, it still operates today because it was so simple, and the tools creating this machine are still there. An electric drive, you can still buy it today for your machine that you bought 30 years ago. That's amazing. And that's what John is driving, and John can't get enough from it, so he decides, there are some apples falling from the conveyor belt from time to time. They're not perfect, they're not shiny. That's a new business opportunity, actually. So why not create some apple juice from our bad apples? I just place here another guy picking the bad apples from the conveyor belt and putting in the mixer. Okay, that's not a super hard job, but instead of the conveyor belt you see on the left side, it's not just a start-stop thing. You actually need to start to control stuff. You need to weight the apples, you need to know, okay, the box is full, you need to throw the apples into the mixer, then the mixer needs to be started, and when the mixer is empty, you need to stop it, because if you would continuously run the mixer would break immediately, and John has a lot of repair costs to cover. He doesn't want that. So the PLC here is doing just three very, very simple things, and John is starting to get the hang of it, but there are so many things that can go wrong. I don't need to explain you that in the robotics community. Just think about your robot demo and 1,000 things can go wrong, but also in this very, very simple machines that you are laughing maybe in your head about, like, that's not a challenge. That is real challenges for small and medium-sized companies and industries, because so many things can go wrong, the same as in your robot. And there's even a famous statement from a very large corporation producing pizzas, Dr. Oetker, Rudolf August Oetker. He said, even if the smallest wheel in the operation is missing, then the machine doesn't run, and this means real consequences. Because such a machine needs to run 24/7 all year long. So John might be very frenetic when the machine breaks, but thanks to his maintenance teams, he knows we can get the machines up and running again. So after all those decades and years, John's a happy businessman. He tapped into the industrial automation. He knows what he can get out of it. It runs 24/7. And he gets the spare parts if something breaks down. And he also did understand that investing in each new machine brings new risks, new challenges that he needs to challenge and face. But he's able to do that because it's very hands down what he can get. And he sees what Siemens, for example, but not the only player, of course, in this market, is producing here. Everything around the conveyor belt. We have sensors, we have safety, we have pipes and pumps and pushers and everything that you might need in industrial automation, Mr. John says. But then, Mr. John Jr. is coming and says, all those conveyor belts, I mean, come on, that can't be it. There needs to be more. I mean, only because an apple is not perfectly aligned on your conveyor belt, Dad, we can't throw it away. There's more to it. And generally, the safety thing, Mr. John Sr., I think that's just a trend. It will pass. But John Jr. says, in those decades of industrial automation that he has lived through, there can't be all wrong, all the stuff that ROS tries and can do. Is it right to 100% replace it, or isn't there something interesting for also here the ROS audience? So he tells his son, John Jr., to focus on what he really wants. He might not want to reinvent the complete industrial automation. He wants to find the apple who's misaligned on the conveyor belt and put it back on track so they can continue to do good business. Okay, John gets a little older, John Jr., and comes back and says, hey, the ROS worlds, there's happening so much. Every consumer vacuum that's out there properly runs ROS. There's so many mobile robots in the industry and interlogistic running ROS. I mean, can it be so hard to get ROS in the industry? And again, John Sr. says, like, yeah, think about the vacuum robot that you bought 5 years ago. It might run ROS, but now it's broken because this one wheel isn't there anymore. What are you doing with it? Yeah, I'm throwing it away. I'm buying a new one. It's just 200 euros. Okay. Yeah, you can't do that in the industry. You can't just say after 5 years, the conveyor belt, the machine breaks down, 100,000 euros easily. I'm buying a new one. That's not how it works. That's not the business cases that they have. Those machines, they need to run 10, 20, 30 years. And 30-year machines, they are very young machines. They are much, much older ones. And for the industrial mobile robots, that's a really cool case, but those are capsules, individual boxes that have well-defined interfaces like the VDA 5050, for example, to talk with the rest of your machine, but it's not directly interfaced in the machine as industrial automation, the classical PLC world is today. Okay, so John Sr. doesn't want to give up. He says, okay, I'm building my robot now who detects the green apples on the red conveyor belts. How hard is that? I mean, you've seen here a couple of ideas from the ROS-Industrial, how to detect stuff. It's not that hard. You will find a solution. Okay. But then he faces the challenge like, okay, I can grab my apple, and now where do I put it? Okay, in the mixer, like the human before. pick the apples, I pick the apples, I pick the apples, and then, oh damn, the basket is full. Like, where do I put the next apple? So he needs to interface with the mixer. Same with the conveyor belt. There are coming a lot of green apples, and he says like, damn it, I can't have a robot arm fast enough to get all the apples away. So I might need to stop the conveyor belt just for a simple second. Doesn't kill my complete machine, but I need to stop it. And the thing with safety, I was talking again, like the robot arm, it moves so fast, so it might not be the best idea to just have it running there without any safety interferences. So he's thinking, and he's looking into the market and sees like, okay, what's out there? And he sees, for example, CSEI, a company, a startup from VZL, doing apple pickers with robot arms that are great algorithms, great applications that he can use. And on the other hand, he sees on the last ROS-Con a talk with BMW and Siemens, talking about a similar problem, integrating robot arm, ROS algorithms with conveyor belts. He says, that's exactly what I want. And today, Siemens is actually offering this architecture for everyone here in this room and in the online audiences. You can buy and get this technology today. We're calling it ROS-I. It just combines those two worlds, but that's not the point. It's just a vehicle to bring ROS closer to industrial automation. And besides what we're doing today, also Siemens is going a step further. There's the future of software-defined automation coming, shown and brought to the world by nonetheless our new CEO of Siemens during the get-together of robotics 2 weeks ago. There is something happening, and industrial automation with the low-code tool TIA Portal needs to evolve, yes, but we all need to understand where industrial automation is coming from in order to change it. To summarize it, I wanted to bring you 3 distinctive states of my talk. We have the just PLC only operation, and we have the young John Jr. wanting to do everything with ROS, and then the advanced hybrid thing. And for me, there are 5 distinctive points here. In the hardware, I think I mentioned this more than enough. The automation world, it works. You have a sensor, a simple ultrasonic sensor. It has very simple interfaces. If it breaks, you can get a new one, and it will be compatible on the electronic side. That's cool. On the ROS side, today there are thousands of adapters working great, but think about this one sensor that you just hacked there together and worked into your use case. What will happen in 10 years if this provider says, I'm not producing this anymore? What do you need to do in order to get your sensor back into your machine so that everything works again? I think that's something not the maintenance team can do easily. That's something where you as ROS developers need to step in. So in a hybrid way, why don't use both? Just use the plain old simple but working hardware ecosystem of industrial automation and get all the goodies of the software of ROS to it. Towards maintenance, like I mentioned before, Siemens has this amazing low-code tool called TIA Portal. It works, and it's known, and there are also other tools like that from other brands, yes, but the interesting thing about it is that it's just one tool to maintain, to understand what's happening in your machine, to update it, to upgrade it, to change it, to customize it. It's just one tool. And if you ever need to maintain your ROS machine, you're probably not sending your sales engineer there. You need to send a ROS expert there at the moment. In order to change that, we heard there some great ideas in the talk earlier before. We also will have a talk 2 days from now during the ROS-Con addressing this, how to find problems from the ROS world and the industrial automation, combine them and also fix them in production. Also the changeability. There's a statement that came to me that I find quite controversial, and I think that you will find it also controversial. is that from a solely end customer perspective, industrial automation as it is today is more open source than any ROS machine that you might think today. And that's because in this area of software-defined automation, there are not yet all the tools there that we have from the industrial automation. Tools like behavior trees or intrinsic might get there someday and might fill this gap, might fill this transparency gap that's needed in order for end customers to really change the machines. But right now, you're probably shipping black boxes, you're shipping binary codes formats, and there's none too little way for end customers to change to something because they are overwhelmed if they need to open a Linux prompt. They need something very simple. And for that, there's another ROSCON talk happening where we try to nurture this ecosystem around behavior trees and try to get more transparency and changeability into the ROS world. All right, for me, the biggest change and difference between when it comes down to using PLC and using ROS is that the PLC environment, the classical industrial automation environment, is meant for highly deterministic environments, and ROS is absolutely fantastic for working in non-deterministic environments. And I think combining those two approaches and finding the right slider of ROS versus traditional automation in your application might get you further than trying to rethink everything with ROS. And we are more than happy to talk about those kind of things during our upcoming ROS talks and our workshop where 12 or 14 people will come and test our concepts out and give us feedback. But for now, I'm just here to say thanks for your attention. And please visit us at our booth because we're also happy ROSCON Gold sponsor, so there will be lots of room to talk with our team. Thanks.